Question number 3. Now in this lecture we are going to find out time complexity for this method over here. Actually this method looks like the method that we created in our previous lecture, but we have some differences over here. As you remember, in our previous lecture, when we were calling that print pair methods for this array, it was taking the first element, then printing out the first element with itself, then with the other numbers. But in this case, we will take the first element and printing out with the next elements, and continue to the second element and printing out pairs with the next elements, not with itself. And here you need to take into account that when we take, for example, 3, it's not printing out the previous elements. So we are not going to print out pair 3 with 1. So as you see inside this loop, the second loop starts from I plus 1. Basically, in our previous video, it was starting from 0, but in this case, it starts from I plus 1. That's why we call it unordered pairs. Now, if we run it for this array over here, the first thing that's going to do, we'll take first element and printing out the pairs like this. So as you see, it's not printing out with itself, it's just printing out with the elements that are located after that element. Then in the next stage, it's going to take the second element and print out the elements that comes after the second element. And at the end, it's going to take the third element and print out the element that comes after that element. So for the last element, we are not running it. Now we need to find out the time complexity for this piece of code over here. So we can find it in several ways. So I'll show you how to find it in 2 ways. So in previous example, we have found the runtimes based on memorizing common runtimes rule. But we cannot always rely on this. So it's important that you know the runtime and deeply understand it. So here the first method is counting the iteration. So here I'm going to count the iterations. So as the inner loop, which is over here, starts from I plus 1, the first iteration for this inner loop will run n minus 1 time. N is the number of elements in the array, so in the first iteration it's going to run n minus 1 time. Now when it comes to the second iteration, it's going to run n minus 2 times, and in the third it's going to run n minus 3 times, and it goes like this until we reach 1. To find the time complexity, we need to sum up these values over here. So if we sum up these, n minus 1 plus n minus 2 plus n minus 3, and it continues like this until v1. So we can write it like this. So we know from math that we can calculate it based on this equation over here. So this is calculated based on the equation that we know from math. So from 1 to n, we can sum the numbers with this equation, which is n multiplied with n plus 1 divided by 2. So in this case, instead of n, if we put n minus 1 and do some calculation, we will reach like this. So if you calculate it, it's going to be like this. So this is our time complexity. Now we learned that we can remove the non-dominant terms and constants from here. So in this case, n divided by 2 is non-dominant term, and 1 divided by 2 multiplied with n squared is constants. So we can eliminate them. Then the time complexity will be n squared. So our time complexity for this method is n squared. Now the second way to find the time complexity for this method is called average work. Now here we know that outer loop runs n time. Now we need to identify how many times inner loop runs. So for each step of outer loop, the runtimes of inner loop vary. But here we can think average iteration. So let's imagine that for the first step, the inner loop runs 10 times. So if it runs 10 times for the first step, for the second step it's going to run for 9 times, and it continues like this until we reach 1. Now if we take the average over here, the average of these runs over here will be approximately 5. So 5 means that we are dividing 10 by 2. So this means that if the number of elements is so, the average will be n divided by 2. So this means that for the n times, the inner loop will run n divided by 2. So if you multiply n with n divided by 2, it's going to be like this, n squared divided by 2. So we can eliminate 1 divided by 2 from here, so the time complexity becomes n squared. So with these two approaches, I have explained how can we find the time complexity for this method. So hopefully everything is clear about both these ways.